So today we're just going to cover the function part, and we do the sub procedures next week. I was kind of torn between which one should I do first, but since I already have the course shell set up this way, we'll do the function, and then we'll do the sub next week. Okay, and they're very identical in certain ways, but there is a slight difference between the two. One is where you'll see that one returns something, one does not. Okay, and Visual Basic is probably the only language that I know of still use the term sub-procedures and so on. Whereas most other languages like Java and JavaScript, PHP, and so on, we use those, return those either just function or we call those methods. Okay, and so let's go over this part, the function procedures. But before we do that, I want to go over one thing about the section 5.4, program design. So you also have a kind of real understanding of what that is. Why is it important? So I'm going to use this slide here. Again, for now, this is going to be just kind of a little bit boring stuff, but it's important to know the concept first. Okay, so we talk about modular design in computer science or computer programming, and we always have a different approach to design or how you tackle the problem. And we have what's called a top-down design and also a bottom-up design as well. Okay, top-down would be like you will tackle the problem. You start from the top and you go down into smaller pieces, and you will solve problems that way. The other way, where you would tackle the other way up, you will solve the small problems first and you go up the other direction. Okay, so you hear these two terms very, a lot of times if you go into programming or into computer science, is the top-down design or the bottom-up design, and also the structure, and we have also the object-oriented programming paradigm. Okay, so for example, you have a problem to solve, and then you have the three input, three pieces: the input, process, output, common thing, right? If you remember in chapter 1, we talked about the diagrams. So what kind of diagram is this again? Do you remember? We use the flow chart, we use the pseudocode. This is one of the other ones. You remember what's it called?
Hierarchy.
Yeah, the hierarchy, right? So you read from top and then left to right, right? So you have the problem, you go down and then you read the input, and then there's no more there. So we go to the right and then down to process it. We're down with this box and then go with output, right? So this is a really high level diagram of how a program should be solved. Okay, so if you look about the top-down design, is you break down each of those boxes, you make it into smaller and smaller components. When we call those smaller components, we call those modules. And modules could be represented in terms of a function or a subroutine. Okay, the idea of a module is something that you can use again and again and again, and that's the idea of programming design. Okay, you want to use a code. You want to create some kind of code that you can use over and over again, because it's not efficient to use the same code so many times in your program. So you would put into a package into a module, and then you just use that over again to solve a similar problem. Okay. So the idea here of the top-down is going from the most generic or general component to the very specific. Specifically, I mean very specific to a certain function to calculate the total pay. That is very specific. That's all it does, right? What function does is it just does one thing and one thing only. When you reach at that level, then you're very specific, very low level, and you're done there. If that can be broken down to smaller pieces, keep breaking it down to smaller pieces. Okay, the more specific it is, the easier to maintain and also easier to debug, and then the more efficient your code is. Okay, so if you look at a whole problem, like things like, for example, you write a text program, even a word processor. You can even write your own word processor, or a game program, especially game programming. Okay, you have a lot of these game repeating stuff that you break it down to modules, right? So your character design, the way a typical weapon works, so all this can be put into modules. So you break it down into smaller parts, and you keep breaking until that part cannot be broken down any further, and you stop there. We call this the top-down design or the stepwise refinement. These terms you will hear in computer science or in programming. So I'm going to go right to the example here. So here is the algorithm, or the word algorithm here is really just a step-by-step process of how to solve a problem. Okay? So when you hear the word algorithm, it means how do you solve it? What are the steps? So the program calls for obtaining the input, and then you make the calculation, and then you display the output. Again, input, process, output. Very, very generic, right? Very, very broad. So on this car loan example, we have like two levels here, right? Back to this hierarchy chart here. We have the car loan application. When we start this, we're going to go to the left. We get the input, right? And then we come back out and we make the calculations. We're done with that, and then we display the results. Okay, very simple. But we can break it down further into several layers down, levels down, because the input can be more, can break down to further. What type of input do you get, right? So you want to get the amount. I want to get the duration for that. Is it also input? The interest rate is also input. There could be other input in there as well. Okay, maybe you have some type of tax bracket, right? And then we get, let's say, 3 inputs here, and then we're done with this. So again, the process will be do this first, and then get the duration, and then get the interest rate, and then we're done. Come back up, you make calculations, you go down, you make that calculation into the monthly payment, and then you calculate the first month's interest. No, actually no, you need to go down further, right? You break this down further, you calculate the number of months, and then you apply the formula for the payment of each of those monthly payments. And then you come back out, you calculate the interest rate, and then finally you are done with this part, and then move to the display. The display has 2 different type of display. So you break it down into smaller components, and then you have display the headings and display the amounts and so on. So you can see this example has like four levels down, starting with the application itself. Okay, so it becomes very specific now. Okay, so you break the problem into parts to help you clarify what needs to be done. It's easier to tackle a problem when you break it down this way. And then each step is refined. Okay, you make it smaller and smaller. If it's complicated, break it down until you see you can understand what this part is. Okay, and then you find a solution for that, and then that part could be reusable. So if you find a particular function that can be reused again and again, you put that into a function, and then later on maybe other programs and other parts might want to use that function and then just calculate again, right? So you don't have to rewrite that function again. And then you keep breaking down until you're done. So a top-down method, well, pretty much a structured programming. In terms of structured programming, when we talk about structured programming, we talk about these 3 things here: sequences, selections, or the decisions. We talked about the if and select case. Those are your decisions. And then something called the loops or the repetitions, which we haven't covered yet. We'll cover that in chapter 6. It's also very, very important. And computer programming, you would find that it's almost impossible to write a program without these 3 type of control here, structure here. So when you hear the term structured programming, it's always involved a sequence, because sequence means your lines of code you execute from top to bottom, right? In that sequential order. And then when you do that sequential order, somewhere along the way you have to make a decision, a selection, whether that the selection is true or false, or you make a selection out of 100, which one is it, right? And then if it's not in that case, then you want to repeat that loop or repeat that process again, make sure you get the correct input. So somewhere along the sequence you might ask the user to enter the age. and then we read the age. If it's a valid age, that is decision. Then you want to repeat that same question again, so that's a loop, right? So all these three are all put together into the structured programming. So it's very easy to test, modify, and also easy to understand. We have this in your program. So this is the traditional way of writing your programs. Okay, it's sequentially executed from top to bottom, or from beginning to end. Okay, so this is the usual way of how you write code. When I say traditional, meaning the other will be like the object-oriented approach, will be a little bit different. Okay, so what you're doing now is mostly structural programming, although the language itself is object-oriented. Okay, Visual Basic is an object-oriented language, but we are writing the code in using structural programming. So here we'll use, so in this class we use the top-down design, as you can see. Okay, you will write sequence of code, and then we'll use a lot of these selections or decisions, and then you'll make a lot of loops. We'll do that in the next chapter. And so you have these sequence structures, decisions, and repetitions. So right now we're here. Okay, we did that, a lot of these. We did all these structures, and then this is the next chapter, chapter 6. So chapter 5 is kind of making it to a module. Okay, make your code more modularized. So if you, for example, if you want to write a program to draw a house, if you can write a program to do that, so you have a house like that. Okay. What you do is you will draw, again, if you map it down to this chart, the main program, you draw the outline first. Next will you might draw the chimney, draw the door, and then draw the windows, right, to get that. Okay, and then if you look at this, yeah, it's pretty broad. You can break it down further, right? So we just did that as pseudocode. So when you draw the outline, you draw something like that. That's outline. When you're done with that, okay, you can move and then draw the chimney. And then you can go and draw the door. And you can do the windows. Add 3 windows. Okay. And then you can see that you can break down the door into 2 components. You can draw the frame first and then draw the doorknob. So each of those will be a specific function, right? So it will be the same for the window, right? Yeah. So so the door frame and then the doorknob. So you break those into 2 separate modules. Because later on, if you draw a different door, then you don't have to rewrite our code again. Say, hey, I already have a function to draw the door frame for the bathroom, for the kitchen door, or whatever it is, right? Or in the garage. And then I can draw the knob too. Just call the knob, draw knob function. It will draw that for me. All I need to change is the material type, and then the texture or the color of that door or that doorknob, right? But the function is the same. Okay. So same thing. So if you draw a window, you could break down so you can draw window 1, want to draw the window 2, want to draw the window 3. If you think about this, it's like you have to do that 3 times to draw the same window. So instead of doing 3 times, you make it into 1. So your code can be reusable. And then you could just say, just draw a window, and all there is basically the location of the window. So you pass that location, is the left or the right or the top of the window, and then the window will be drawn, right? And you also pass the color of the material. Same thing we talked about the door, right? So if you have 100 window, it's still going to be used just 1 function to do it. So you don't have to write 100 times. Okay? And so you could say location 1, you pass it location 1 to draw the window. You can do the second location for window 2 and 3 and so on. So it's easy to write, easy to debug, and easy to understand, and very easy to modify. Okay, so we have things in modularized in this way. If there's a problem with the window, well, I just go right into the drawer window code. It's in there. Or in the doorknob, go right into that code and fix it there. Okay? And then the other one is the object-oriented programming, or the OOP. You might hear and see that all the time in the computer science world. But this is a programming, object-oriented programming. We'll talk about this in chapter 10, 11, towards the end of the semester. But it deals with objects. Okay, that's what the object is. Object is like an object in the real world. Object, if you look at an object, has a lot of properties, right? It has color, it has a texture, it has a size, it has some type of other properties, some effects to it. If you have talk about a ball can be, it has air, it bounces, and so forth, right? So all those features are tied to an object. An object can be a physical thing in the world, like using the word, or something in data, like a bank account. Okay, that is an object. Account has a username, has a user account, has monetary data in there, and so forth. So all those are properties. Is it a saving account, or is it a checking account, or is it a investment account, right? It's object, same thing. An object, we have these keywords here, which we'll again talk about later. Mean you can hide data. Encapsulation means hide data. You can inherit, meaning you have parent and then children relationships. And polymorphism means you can morph, you can change its forms. So it's some things that might be hard to understand until you program in that. But it's also very flexible, and it's very powerful in terms of programming a really complex problem. So it's usually used for really complex application. If it's a simple one, you don't need it because it's too complex to use for that. So it's ideal for like if you build a really complex text program, or especially useful for game development, okay, game application, or like even Microsoft Word. If you want to write your own word processor, that could be an object-oriented programming approach. So here we have the different layout of the structured programming and then the object-oriented. You can see that it's like all over the place here, whereas the structure is like very sequential from top to bottom. So you start, and then you go down, and then you receive the input, you process, you return the results, and then you go back and then do it again. Whereas the object-oriented, it's quite complex, because you can have different types of input all over the place. It comes from anywhere, anytime, and when that object is received, an input, what does it do and where does it go? So it's like all over the place there. Okay, so if you talk about a game, right? Imagine that this window is your character. You can have input here by another, 2 or 3 other characters trying to attack you. So you have 3 or 4 different input at the same time, and then your character has to react to those type of reactions, right? So it's really complex. So you deal with a lot of like almost like a 3D world there. Okay. So, but once you understand, but a lot of these structure here can be embedded inside here as well. So object-oriented programming is really fun once you understand the concept. Once you know how to do it, it's very, very fun. Okay, I guarantee you that. So these are just some comparisons between the two. So with that done, you can read more about it. I'm not going to go into detail, but I'm going to go right into the next topic, which is today's main topic, is function procedures. Okay. So what is a function? If you think about a function in the real world, like like your body, right? Your hand, you can do things with your hand. You can grab things, touch things, feel things. All those are functions, right? So your a car has a different function. The pedal has a function. The handbrake has its own function, right? So in Visual Basic, you have some built-in functions, and not just Visual Basic, but most other languages as well. Some built-in functions that you can just use. Okay, so notice again when we do the input from the text field, assign the text field to a data type of integer. We just did that with the character J and so on. Or if you assign it to a decimal or a double type, okay, that Visual Basic implicitly convert the text field, which is a character number of 5, into an integer. Okay, it does that automatically for us. So it's a built-in function that does it. We don't see it, but it does it behind the scene for us. Okay, so it has a lot of these built-in function. Also, when you you know how when you convert that value into a dollar symbol, right? That is also a function. So we have like a, result dot toString, and then we put the character C inside. That is a function. It converts that into a dollar value. Okay? It's a built-in function built into Visual Basic. Okay. Functions have one parameter and can also have multiple parameters. I will talk about that also by passing by value in the data types. So, a function, the definition here is a collection of statements. Okay, it could be 1 statement, it could be 100 statements that performs a task and returns a value. Okay, the one I put in red here is really important. Okay, this is the difference between a function and a subroutine or sub-procedure. We'll talk about that next week. A function returns a value. Okay? It must return a value, and I'll tell you what that means. When the statement, and then when you call the function, we call a function invocation or invoke the function. So functions work like the intrinsic functions, such as cont'd and isNumeric. Cont'd here it means convert to integer. Like I show you in my example on the payroll, that's a CDBL for convert to double, right? It's a function, converts it to a double type. The isNumeric is another function built into Visual Basic to check whether the input value is a number or not. So you can validate that input. If it's not a number, if it's false, then you say to the input user, or hey, you have to enter a valid number. So you can use that to validate your input. So Visual Basic, both the functions and the sub-procedures are usually just called general procedures. Okay, so it's very general. But you, so there's a difference between the two. And so here are some of the built-in functions in Visual Basic. And you may not used this yet. Okay, so here are some, for example, the int here function. And usually functions in sub-procedures, the names are always capitalized. Okay, unlike your unlike the variable names, we usually lowercase the first character of the identifier for variables. So that is the difference. I mean, you don't have to use capital letters, but by convention they are capitalized. So we have the int function here, and the number inside here, inside the parentheses here, is called a argument, okay, or parameters. And so in this case, this function int would take an argument of 2.6 and then return the integer part only. So remember, integer takes the whole number. So in this case, if you pass in this number 2.6, you get the value of 2. It drops the decimal numbers. Okay? And then the char, CHR, if you put in char of 65, this value here, what it does is will convert this character, this is an ASCII code character, and then return the alphabet letter of that character. So 65 is the character for A, right? Capital letters, capital A. So if you want to know what is the letter for number 96, it was char, CHR 96, it will tell you that 96 is maybe, I don't know, the Z, maybe a capital Z. And then this is the other way around, the ASCII code. This is the opposite of this one here. The ASCII for Apple, in this case, it just grabbed the first character, okay? it omits the other ones. So ASCII only takes the first character. It converts the letter A to the ASCII number, which is 65. So these two are reverse of each other. Okay, if you want to know what is the ASCII for letter B, you put ASC here, put the letter B in there, you get 66. Okay, and then the mathed out round is you just round a number to I think it's probably round up, and then it takes two parameters in this case: the number you want to round up, and then the decimal places you want to keep. So in this case, it's just going to be 2.3 because 4 is not enough to round up to 2.4. So we get 2.3 as the result. Okay, so this is some of the examples of the built-in functions in Visual Basic that you can use right away. Okay, so here is an example of the input box. Right, we used before the input, the message box before, or we call the input box, and then we prompt the user to enter some data. Right, we did that in last 2 weeks ago. So that is another function. This function here, like here, input box, please enter your last name, and then so on. So you put the value here, you click OK, and this function returns the input. That's why functions return a value. Okay, it has to return a value. And this is how you would declare your function. This is the syntax for that. The modifiers here, what you see here in brackets are optional. That means it's not required. Everything else is required. Okay, so you have to put the keyword function followed by a name of your function name. This is just like your identifier. It has to be unique. You cannot have the same function twice. There's some exception to that, but that's more of the object-oriented approach. For now, it should be just a unique name, and then followed by a pair of parentheses here. Inside here, you put your parameter list. Again, this is optional. You don't have to have it, but you can. And then you have to also put the keyword as data type here. So if you look at this, it looks very similar to your dim statement, right? You say dim num as integer. Same thing, except function name as what type is it? Why? Because this function has to return something back. So this expression here has to match the data type. Okay? So this function here could maybe calculate your age. So age will be a integer number. So therefore this could be as integer, and then return the age. So the age has to be an integer number. You have to match the data type. So you cannot return a double or a string. Okay? Has to match the same type. And then the statements here again is optional. You could have an empty function. Well, it'll be useless in this case, but you can. But you just have to have the return expression down here. Okay? So the modifiers are things like private, public, protected. We'll talk about those later in object-oriented. But for now, you could use private or public. It doesn't. I think it doesn't really matter now. But you don't have to use it. It's fine too. If you don't, it'll be. I think it'll be defaulted to private. So this is just some of the modifiers, and you see that in the example when you look at the code, right? If you let me just show you real quick. So see that here. You see private, okay, private, public. Then the sub. This is a subroutine, so it's sub. The name of that is a unique name, followed by parentheses, and then this case will be different because this is a special subroutine. This is what's called an event handler. That's why this is handles here. Okay, but we'll see some examples. We'll do some examples of how a function looks like. But very similar to this. So Parameters. Parameters are just like your variables. Actually, they are exactly your variable names, right? And they are stored inside the function head. It's a list of variables to store some data. So really just a memory location in the program. And so here it says each parameter in the list has procedure scope. Again, procedure scope just means local scope. Okay, remember we talked about local scope? It's local to the function or that procedure, right? Okay. There is a difference, a kind of subtle difference between the keywords parameter and argument. Okay, so because it is a little bit different. When we talk about parameter, we're talking about the actual variable names inside the function or the subroutine. When we say argument, we're talking about the values we pass to that function. Okay, so I'll show you what that means here. So here we have a function that has one parameter. So this is a function here called F2C, Fahrenheit to Celsius. So the keyword function followed by the name of the function. Inside here we have one parameter called T. Okay, this T here is a double, so you can see that it looks very similar to how you dim your variable name, like down here. We say dim first name, first space as integer. Except in here, you cannot put the word dim inside. Okay, yeah, it won't let you do it. It automatically knows that it's a local variable. It's a variable, so you could just omit that dim keyword. But you still have to specify the data type. Okay, so if you have two of them, you put comma and then put the second one. You have to also specify the data type. So this function takes one parameter, or we should say accepts one parameter, or receives one parameter, and it's going to do some processing, and it's going to return a value, and the value returned is going to be of type double. Okay? This double here applies to the whole function. This one here just applies to this T. Okay, so don't confuse between the two here, because whatever is inside here is it does not have to be the same as the function return. I could have this function receive a bunch of numbers and then in the end return a string. Okay, so you can return any type you want. In this example, it's going to return a double back, and as you can see, it takes a formula here to convert to Celsius. So this is the formula 5 divided by 9 times T. This T is this value here. So whatever this T is, it's going to be placed in here in minus 32. This calculation returns the Celsius in double, and then returns it back as double to wherever it's being called. So down here, we have another function. It's called first name. It takes a parameter called full name as a string type. This function also returns a string. Okay, so inside this function, just like any subroutine we did earlier, you can have all kinds of variable names you want. It's a local. This full name here is local to this function. This T is local to this function only. It does not exist outside. Okay, so this so this have procedure or function as local scope. And then we have a first space as integer, and then first space is you get the full name here, which is this name, whatever that name is, dot index of this another built-in function built into Visual Basic will give you the first space character. If it finds the first space character, then it stops there, and then it just pulls the first name. So in this case, it would be like if you have a name of, let's just say, John space Doe, and it want to grab only the first name, which is John. So it's going to look inside the string of the full name, J-O-H-N space. Oh, it finds the space, stops there, and then returns the word John to the first space, and then it returns that string out will be, in this case, will be just John. Okay, so this function does that. So again, return a string. Okay. So look at this again. I showed you earlier what those different parts are. This is like the anatomy of a function. The function keyword, the function name, a parameter. Okay, so this is what we call a parameter. A parameter is inside the function name. The whole thing here is inside this parentheses. What's called a parameter. Okay, and then the data type for the parameter, and then the data type for the return value for this function. Okay, and then here we have another function that takes multiple parameters. This one takes 2. So if it has more than 2 parameters, then you want to separate each with a comma. And so this here you have a function called pay, and this pay here returns a double. So the last statement returned should be a double type. It has to match. Okay, so it takes 2 parameters. The wage, this wage is double, and hours is also double. So you have to do it separately. You cannot put wage comma hours as double. You cannot do that like we did in the dim case. It's a little bit different here. So takes 2 of them, and the order is important. Okay, so you want to make sure the order is important, because later on when you use it, you want to pass the data to this pay function. The order they go here have to match the data type, as well as when you do your calculation, it's also important. If you switch numbers around, then you get a completely different result. Okay, so it's really important to know what they are. And then inside this function, you will declare another variable, this local variable amount, and then here we have our select case, right? We select, this is like the overtime pay we just talked about. We did in our example. So we test the case hours. If it's less than or equal to 40, then we have the regular pay, right? If it's over than that, then the pay will include the overtime pay. So here's the regular pay here, plus your overtime pay. And you add together, you get your total pay, total amount. And then at the end, you return that amount back, so you get your pay for this function. Okay? And so you use the wage in your function here. The hours are also used here. So let's go a little bit further. Here you have 4 parameters. As you can see, each of those have to be declared separately, and you have to declare each of those their own data type. So the P is like the future value function, or some type of investment. The P for double, R is double, M integer, and T integer. This is really kind of bad, the way they name here, because it's confusing. What is P? What's RT, right? So that's why down here you have to explain again. P is for principal, R is for annual rate, and so on. It would be nice just say principal, annual rate, number of times, number of years, right? And then you don't have to comment in here. It's understood. And then this whole function here return a single value of type double. Okay? So a function can only return one value. It cannot return 2 or 3 different values. So it doesn't matter how big your function is. In the end, when you return it back, it's just a single value returned. Okay? So that's why functions are very, very specific to do one thing and one thing only. Okay? So here we have 4 parameters past this function here received from somewhere else, and then we do the calculations in here, and then we turn the total here back as a double type. Okay? So here it says every function has a data type, just like your variables. And then these are some of the data type we talked about. Bless you. And then the data type is specified here at the end of the function name as double or as integer or as string and so on. So this is how you do a function call, really. So we did this before, right? We did total is equal to double is equal to, we didn't say sum, but we read that from the text field. txt input dot text. In here, you put the function on the right side because it's return a value. It has to return a value, so that the value can be assigned to the total. So this is what's called a function call. Okay, we'll talk about that in a bit here. So this sum here, if you look at the function head here, declaration, the sum, we take one parameter as double, return as double. So this double here has to match whatever this total is going to be. So this function returns a double, so therefore this total cannot be other than double. If you put a string here, it will fail. If you put an int here, it will fail. Okay, it has to be its own kind. And then if you look at the sum, we just call the sum by the name of the function or the subroutine. In this case, the sum of the function. And it takes one parameter. And then this is value 1. This is called an argument. Okay? So when you call the function and you pass a value to that function, this value here is called the argument. And this is referred to as the parameter. And sometimes you'll see that those two terms are used interchangeably. But technically there's a subtle difference between the two. So when I say argument, I'm talking about the data passed to that function. When I say parameter is the actual variable name or parameter inside that function head. Okay? So how does a function get called? So every function, if you want to use it, you have to call it. Same thing we use subroutine. Right, when we press the submit button and the button, we have to call the subroutine. You have to activate it. If you don't, it doesn't do anything until it just sit there, and it's not being used. Okay, just like when you're to go grab a cup of coffee, you have to command it to do something, right? It will just go do it itself, or does it? I don't know. So in this example here, so functions and subroutines and computers. Programming always required some type of initiation. Unlike our brain systems, they are anonymous systems, so they work automatically. But in programming, you have to call it. Okay, so we invoke the word invoke or invocation. If you hear those terms invoke or call a function or a procedure, same thing. We call it by using its name. And you pass any arguments to that function or the subroutine. Okay, if there's any. If there's none, then we leave it blank. We still have to put the parentheses after the name. And a function can either be called on the right side of the equal sign, we call the assignment operator, or in an expression. Okay, it's really important to understand this part. So a function, either on the right side or an expression. So here's an example. So we have a function called sum. I told you earlier. This function here takes two arguments, right? Value 1, value 2. Whatever those are. In this case, it's a variable name. It could be like 5 and 10. And then the name of the function, we call it the function name, and then if it takes two parameters, then we put the arguments in there, and then it would sum it up and then return back. We'll assume it's some type of either a double or integer, and then if it's 5 and 2, we get 10. So now 10 is assigned to total. Okay, so it's on the right side of the equal sign. Cannot be on the left. Okay, it cannot. This is the first part on the right side of the equal sign, assignment operator, or an expression. Expression is this. This is an expression, right? A condition. We want to know if the sum of these two numbers, so we say if 10 is greater than 100, right? So instead of saying 10, you use the function to calculate some values and return the number back as a value of 10. So we could say, pass 5 and 2, you add them together, you get a 7. So you say if 7 is greater than 100, so that's fine. You put inside an expression here, like this, or on the right side of the equal sign only. Okay? And then all the arguments are not optional. There's an exception to that, but we'll talk about that next time. So if you have a function that takes 3 arguments, you have to pass all those 3 values to that function. So the number of arguments must equal the number of parameters. Okay, that's just very, very straightforward. And again, the data types of the arguments must match the data type of the parameters as well. So if you were to pass an integer to a function, then that number has to be integer. If it's not, then you have to cast it or convert it. Sometimes you can, sometimes you can't, depending on the data type. So here's another example. We have a function called sum again. The keyword you see by value here. This is from an older Visual Basic version. I think Studio 12, 2012. Usually it requires you to have the keyword by value in front of it. Okay, that means that you're just passing a copy of the actual number to this num1 and num2. But now you don't see that anymore. So by default, it's always by value. And we'll talk about that later. So num1 has a double, num2 also is double. The sum returns a double. So you declare a local result to store the result of these 2 numbers. You add them up, you return the result back to the sum. Okay? So you call it here, again, sum, value 1, value 2. You call the function. It does calculation, returns back to here. Okay? So value 1 goes here. I told you the order is important. In this case, it's not. Right? In this example, it doesn't really matter because all you do is just add them up. But in some cases, it's really important. Depending on what if you want to test here. If num1 is greater than num2, then do this, otherwise do that. And that's important. Okay? But in this example, it's really not important. Just show you that they have to match the data type and what they go. Okay, and then the double result has to match the total. Total here will have to be also double type. Okay. So passing variables by value. Value means we are actually passing a copy of that value to the function. Okay. Because every variable that you declare, we talked about this from the beginning of the semester, that a variable is really just a memory location, right? It's a memory address that stores some value. So that value is the one that is passed to the function and not the memory address. Okay? So we have a variable that has num equals 5. If you pass num to a function, then we're actually passing the actual value 5 to it, just a copy of it, and not the actual memory address. So we call that passing by value. Okay, so by default, all the values are passed to a function or a subroutine by value only. Okay, so the keyword by value here, again, this is default. It's I think it's optional now, but is the default by value. And a copy of this number, whatever the value is, so it's not the actual memory location of the other where it's being called from, but you just receive a copy of that number. And then they're completely independent. So if you change the value inside the function, it does not affect the outside. And I'll tell you what that means. So so in this example here, So we have a subroutine, right? It's a handle, so it looks very similar. It's a click event. So you click on this button, it does this, right? You have a number set to 2, and then we call a function here on the right side, right? On the right side, triple. You pass the num right here, 2 to it, and the function down here, we see the num has integer. You can see that this function here has the same name as the num here, as here. Although they're the same name, they're completely different. You just call it the same because they're local to each other, right? It's local here, it's local here, so you can call the same name if you want. It's fine. You can use different name, that's okay too. So you pass the num, which is 2 here, to this function triple. And then down here, we say num, which is this num here. We got to multiply itself 3 times, or by 3. We get whatever the number is. In this case, it will be 6. Then we return 6. Okay, return 6. And then this first box will be 6. This second box will still be 2 because it's just local here. Okay, so just a copy of that one there, and so on. So we'll take a break, we'll come back, and then we'll do some examples of the functions, how to declare some functions, and then do some calculations in the function, and so on. So I'll see you back in 10.